Welcome back to Math Master. This is Sarita. Today we'll discuss about the continuation part of yesterday video, that is lines. So we have discussed what are lines and what are curved lines, what are straight lines, and all these we have discussed. Today we'll see how many number of straight lines can be drawn with the given points. We'll see, take one point. This is the point. You draw a straight line passing through this point. See, this is one line we can draw, and this is another line we can draw. So similarly, we can draw all these lines through that point. Or these three or four lines are only these four lines are passing through one point, and no other lines can be drawn. Yes, we can draw an infinite lines. Yes, we can draw an infinite lines through one point. That is the line passing through a single point. So you may come across a question that how many number of straight lines can be drawn through a single point. So your answer will be infinite. Okay. So similarly, how many number of straight lines can be drawn through 2 points? We'll see. See, these are 2 points. Now, so there is a possibility of drawing a straight line. Yes, these are the 2 points. Yes, I have drawn one straight line. Is there any another possibility of drawing straight line passing through these 2 points? Will you try? No, because there is no possibility of drawing any other straight line other than this. That is why we can say to draw a straight line uniquely, we need exactly 2 points. So with 2 points only, we can say the straight line is unique. Okay? And okay, with 2 points, we can draw a straight line unique. What about 3 points? 3 points. 3 points are there in a plane, and how many number of straight lines can be formed with these given 3 points? So as I said, to draw a straight line uniquely, we need 2 points. So take any 2 points combination and draw a straight line. Then count the number of straight lines that can be formed with these 3 points. Okay, see, I have taken these 2 points as one combination. I have drawn one straight line, and take another 2 points and draw another straight line, and take these 2 points combination and draw another straight line. Is there any other possibility of draw a straight line? Yes, I have taken these two combinations. These are points A, B, C. Okay. AB combination, one combination, AC, one combination, BC, one combination. So there is no other possibility of drawing a straight line other than these three. So how many number of straight lines can be drawn with these 3 points? Yes, there are three number of straight lines can be formed with the given 3 points. Now a question arises. Is this the only one way to draw a straight lines with the 3 points? Is there any rule that the 3 points always be like this? No, right? Because the points may be in any arrangement, not only this way. So the arrangement can be like this also. If those 3 points are like this, can you show me these three straight lines with this arrangement? It is not possible because these 3 points are in the these 3 points are in the same straight line. Yes, these 3 points are in the same straight line. That is why we cannot show more than one line through these 3 points. Then, if there is a question, how many number of straight lines can be formed with the given 3 points? Then what will be your answer? Or whether your answer is 1 or 3. So that can be anything, right? Then what is the exact answer? For that clarification, there is a collinearity comes into picture. So we'll see what is collinearity. So what is collinearity? What are collinear points? Now we'll see. See, as just now we have discussed with the 3 points. Those 3 points arrangement may be like this is one possibility. And those 3 points may be like this on the same straight line. So, by the arrangement of these points, then only we are saying these are collinear and non-collinear and like this. So, come to the definition of collinearity. Three or more points, three or more than 3 points can said to be collinear if they are on the same straight line. So what is the definition? Three or more than 3 points are on the same straight line. Then those 3 points are said to be collinear points. Okay. So P, Q, R are collinear points. Then can you say A, B, C are collinear points? We can't because B is not on the straight line which is passing through AC. That is why A, B, C are non-collinear. It is non-collinear points. And this P, Q, R are collinear points. Collinear points. So just now I asked the question that is with the 3 points, how many number of straight lines can be formed? That completely depends on whether the given points are collinear or non-collinear. Okay, now we'll discuss. So with the three non-collinear points, how many number of straight lines can be drawn? As we see just now, so there are two possibilities. What is if the points are collinear? If the points if, if the points are collinear. If the points are collinear, whatever may be the given points number is, that the answer is always 1 because with the collinear points we can draw only one straight line. Okay, so if the points are collinear, only one straight line can be formed. Okay, one straight line can be formed if the points are non-collinear. If the points are non-collinear, the points are non-collinear, then your answer will be 3 because I asked the question that with the 3 points we can draw only 3 lines, right? See, these are 3 points. So just now we see there are only 3 possibilities are there with the 3 given points. With the 3 given points. Okay. So like that you have to answer, because in the recent competitive examination the way of asking question is completely different, and in the previous they used to ask the question directly, means straightforward answer, but now the trend is completely changed. They are asking the question very logically. So before answering any question in the examination you must read once or twice, and along with question you should read the options completely. So don't just look at the first option and fix to it. Okay, you should read all the options, then and the question must be understood, then only you can answer perfectly. So that is the reason, for anything, for any competitive exam, you have to remember this one. Okay, so now for example, how many number of straight lines can be drawn with 10 collinear points? 10 collinear points. 10 collinear points. Tell me the answer. 10 collinear points, right? Yes, I said you how many number of points can be. Whatever may be the number of given points. If the nature is collinear, then your answer must be always equal to 1. Okay? Because even if you take 2024 collinear points, then also your answer must be 1. Okay? And similarly, if 4 non-collinear points, if the question is how many number of straight lines can be formed with 4 non-collinear points, then what is your answer? So if you take 3 points, you can simply draw and count and you can answer. So if the number of points increases, how can you count the number of straight lines be formed? See, we'll see the number, because as we said, for any 2 points we can draw a straight line uniquely. That is the reason, to draw any straight line, we require 2 points. So if the 4 points are there, see, if the 4 points are there, you must take 2 points at a time and draw a straight line. So he mentioned 4 non-collinear points. So you take 2 points at a time, then draw a straight line. So that can be represented like this. 4C2 means 2 points. Take any 2 points combination. So this will be your answer. With 4 non-collinear points, how many number of straight lines can be formed? 4C2 number of straight lines can be formed. And this can be expanded like this. Start with 4 to below two numbers. Start with 2 and below 2 numbers, that is multiplication of 2 numbers. 4 into 3 divided by starting with 1 and up to 2 multiplication. So 2 twos, so 6 number of straight lines can be formed with 4 non-collinear points. Then the next case is there only one way possible that always points are collinear or always points be non-collinear? There is a combination of collinear and non-collinear points also. Then in that case, how can you count the number of straight lines? We'll see now. See, they have given 10 points. Out of 10 points, if 5 are 5 are collinear and 5 are non-collinear. Then how will you count the number of straight lines? So just before we have seen that with the total non-collinear points, you can simply say if 3 number of points are there, 3C2, 4 number of points are there, 4C2. Like that, if n number of points are there, nC2 number of straight lines can be formed. If those all are collinear, you can simply say only one straight lines can be formed. Then with this combination, how can you count a number of straight lines? See, out of 10, 5 are collinear, 5 are non-collinear. So, we'll see with 10 points, how many number of straight lines can be drawn? Take 10 points, so 10C2 possible ways are there. Out of these 10C2 possible ways, he mentioned that 5 are collinear. So, subtract 5, 5C2 from the total number of straight lines, and we should not left this as like this, because one more straight line is added, because with so we are completely removing these 5 collinear points combination. But with these 5 collinear combination, we can draw one straight line. See, if you have 5 points like this, can you draw one straight line or not? You can draw, right? So you should all add this straight line also. So in this way, you can count a number of straight lines. So total given number of points, the combination, you can draw 10C2 straight lines. With these, out of 10, 5 are collinear. That is why you have to subtract 5C2. With these 5 collinear points, you can draw one straight line. That is why you must add 1. So this is the way to calculate the number of straight lines formed with the given points. Okay. So take a note. In the note, we'll summarize what we have discussed in the points format. These are the two note points. The first one is number of straight lines can be formed with n non-collinear points, which is equal to nC2. You can write it as n into n minus 1 by 2, and the number of straight lines can be formed with n points in which m points are collinear, which is equal to nC2 minus mC2 plus 1. So this you have to remember for solving the questions. Now we'll see the next definition, that is line segments. What is line segment? So take any 2 points, and the set of all points starting with A towards B. So this we call it as a line segment. These are not exact, these are all points, and these points are arranged in a straight way from A to B. Okay, so this we can represent as AB line segment. It has both the endpoints. The endpoints are A and B. These both are endpoints of the line segment, and as it has endpoints, we can measure length of the line segment. We cannot measure length of the line because it doesn't have endpoints. But we can measure length of the line segment because it has both the endpoints. Okay. This is what a line segment, and we represent line segment with AB. It means it is a length of the line segment. Length of line segment means it is distance between the points A to B. Okay, that is what about line segment. Then we'll see the next definition, that is ray. We'll see the next definition, that is ray. Ray is nothing but if you extend the line segment only at one end, that is called a ray. Take one line segment and at one end you extend it infinitely. This we call it as a ray. This is what a line segment, and we are extending at one end. So it can be extended up to infinity at only one end. It has only one end point, that is we call it as a initial point. A is the initial point, and we call this ray as a AB ray. We call this as a AB ray. And can we measure length of the ray? No. Why? Because it doesn't have one end point. It has only one end point, that is initial point, and we don't know what is the end point of that. Then how can we measure? For line also, we don't have two end points. That is why we can't measure the length of the line. In the similarly, we cannot measure length of the ray. Okay, this is what about the ray. Next, we'll discuss about the plane. Okay, the next definition is plane. What is a plane? We always take examples like, see, take this board as a plane, and take this as a plane, and take this as a plane. Like this we take. Why should we always take a plane as a square or rectangle shape only? Actually, what is plane actually? We'll see the definition of plane. So take any figure in the plane. Okay, take any two-dimensional figure. That may be triangle, that may be square, that may be rectangle, whatever it may be. In order to say this is a plane, you take any 2 points in the given figure. Take any 2 points. If you connect these 2 points, no, this must be belongs to the figure itself. If it doesn't belong to the figure, that we don't consider it as a plane. See, example, take this shape. As I said, you can take any shape. So this is also a figure. You take 2 points in the figure. Okay, 2 points and join these 2 points. I am joining these 2 points. But in this region, is this belong to the figure? No, right? That is why we can't say this is a plane. So that is what the definition is. If you take any 2 points belongs to the same figure, then we consider it as a plane. That is why we take always square or rectangle or triangle as a plane. So triangle is also a plane, but for our convenience, we take always square or rectangle as a plane. Okay, Euclid defined plane is also an undefined term because plane itself doesn't have any particular definition, but he explained it as a like this. Okay, and he said we can extend the plane in all the direction. In as like in the straight line, we can extend in either side. In the plane also, we can extend in the diagonal way and in the side view and at the top, at the bottom. So we can extend the plane in all the directions. So as we discussed in the straight line, number of straight lines can be formed with the given points. We now also discuss the number of planes passing through the points. See, with one point, how many number of planes passing through this? See, we'll see. Is this the only plane passing through the point? Doesn't it have another option? Yes, we can draw the number of planes through a single point. So with this point, you can draw a number of planes. Okay. So how many number of planes can be formed with the single point? So infinite number of planes can be formed. Okay. So with 2 points, how many number of planes can be drawn? With 2 points. See, you have 2 points. How many number of planes can be drawn? So with 2 points, this is one plane and this is another plane. This is another plane. This is another plane. So you can draw infinite number of planes with 2 points. So with 1 point also you can draw infinite number of planes. With 2 points also you can draw infinite number of planes. And with 3 points, with 3 points. So with 3 points you must have a plane joining these 3 points. With these 3 points. I think, is this the only one way to draw a plane with these 3 points? Yes, this is the only one way you can draw a plane with 3 points. As like the straight line, in order to draw a straight line uniquely, we need exactly 2 points. So similarly, here, in order to draw a plane uniquely, you need 3 points. So with the 3 points, we can draw a triangle. So that triangle is the starting plane. So that is the smallest plane in the geometry. That is the smallest plane in the geometry. That is triangle. Okay. And so with the 3 points, as I said, we can draw a plane uniquely. So if the 3 points are collinear, how many number of planes can be drawn? Not even one. Not even one. See, if you draw these three lines, you can draw only line but not plane. That is the reason if the question is how many number of straight planes can be formed with the given 3 points. If he doesn't mention any nature of the points, then your answer will be cannot be determined. If those 3 points are non-collinear, then your answer is only one plane can be formed. If those 3 points are collinear, then your answer will be 0. Okay. So this is what about the basic definitions of all the lines and line segment, ray, and every definition I have discussed, and we'll see some more definitions in the next class. Okay.